everyone, July the 10th. Well, I stopped working around 8:30 today. Could have continued working, but decided not to. Decided that, this you can always work more, right? You can always work more. All right, what is this? Meeting rooms number 3. You're given an integer n rooms numbered from 0 to n minus 1. You're given a 2D integer array meetings, where meetings I is the start and end. A meeting will be held during the half-closed time, so end is not included. All the values of start are unique. Meetings are allocated to rooms in the following manner. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. When a room becomes unused, meetings that have an earlier original start time should be given the room. Return the number of rooms that held the most meetings. If there are multiple rooms, return the room with the lowest number. Let me get some water before coming back. All right, so we have these meetings and we have n rooms, right? And we say each meeting will take place in unused room. If there's no available room, meeting will be delayed. So we just delay. And when a room becomes unused, when a room is available, the meetings that have the earliest original start will take the room. So we have now 0, 10, 1, 5. We sorted by start, 2, 7, and 3, 4. And the start do not repeat. That means when you have a case where one room is available and all the other have multiple meetings, there's always going to be one meeting will take the room. Now we have 2 rooms, right? So we have room 0 and then room 1. So first will be 0 to 10 because that's the first. So this one's gone. And then second will be 1 to 5. This one's gone. Now we start at 2, but the earliest end is 10, the earliest end is 5. So when this one ends, we'll put 2 to 7 here. That's right. And then this one will end at 7, so we put this one here. Okay, I'm not sure because my result is different from what the room was that held the most meetings. That held the most meetings. How come it's 0? At time 0, both rooms are not being used. The first meeting starts in room 0. Oh, we cannot sort. Wait, can we sort? No, we can sort. At time 1, only room 1 is not being used, so the second meeting starts in room 1. At time 2, third meeting is delay. At time 3, delay. At time 5, the meetings room in 1 finishes. The third meeting starts at 1. For the time period of 5 to 10. Huh? The third meeting starts in room 1 for the time period 5 to 10. Why 5 to 10? This is 7. Oh, shoot. My bad. My bad. Damn. Okay, I'm doing it one more time. So to 5, right? And then now the current time is 5. We don't put 5 to 7 in because we already have 5. So this one essentially is basically we start with 5 to 10. Yes, it's 5 to 10. Okay, so 5 to 10. So now the both are available, but this one is smaller, so I put the last one is ending at 11, right? Ending at 11. Okay, so we do sort it. Let me try one more time and try this one, and then we can kind of see what we're gonna do. So we have 3 meeting rooms now, right? And we need to sort. It's already sorted. So we have 120, 210, 35, 49, and 68. So essentially, for this, we're going to need to record the end time. Okay. And this I can see it is going to be a maybe priority queue. That's what I think. A max heap. But anyway, so we start. So the end will be 20, right? Because what we're gonna put in the priority queue is going to be like 2010, 20. Yeah, 20 0. I mean, we'll start with 0 0 0 1 0 2, and we're gonna do negative. So the max heap. So this one comes out. So we do 20, right? So next comes. So we compare this one first, right? So next, this is 20. So this comes up. So this one will go to 10, right? Because we don't have anything. We start with this. Next one comes, we start with 0. So 0 plus 5. So we do 5. Next it'll be this one, because this one's the smallest. Oh, we do min heap. Oh my goodness, we do min heap. Yeah, we do min heap. So this one plus this will be 14, right? Min heap will do this one. This one will come out at 18. So at the end, we'll have, we need to have a counter as well. Who gets? So this one gets the most. I think that should be it. I want to know min heap with element being a vector, being a pair. Do I have to do a custom? So this is a max heap. Okay. Yep, I think this is exactly what we want. So what we're gonna do here is 2402. Use a min heap to keep track of which room to use. The min heap will first compare the end time of the meeting, right, in each room, and if the end time is the same, compare the index. We also need to sort meetings by their start time. And then we go through the meetings one by one. Assign it to the room at the top of the min heap. Finally, a counter to keep track of the room that has track of the number of times each room is used. So we call it O(n log n). Actually, no. Hold on. Meetings is of a different length. Meetings is of a different length. So we will go O(n log n). Okay, we said O(n log m). That's meetings. We sort it first. Plus, we go through m times, right? And each time we will do a log n, right? Where technically we also have plus n at the end, right? Where m is equal to length of meetings. Okay, so we sort first. And then priority queue. Okay, actually I don't know what's the syntax. Priority queue. We have to do this. Okay, so std pair int, and we need to do a vector. Yeah, a vector of std pair int, and std greater, right? Because they're using greater to make it greater, but we have to put the thing as well. So greater pair int main heap. Okay, so that's the setup. And we'll say for int I equal to 0 I smaller than n I plus plus main heap dot push 0 I. Okay. Now we also need a vector of counter size n. So for const auto m of meetings. Okay. We need to pop it first, then push it. So we say auto room main heap dot top main heap dot pop. Okay. So what do I do then? I do main heap. So room gets used, right? This is when the room gets used. So we say counter room dot second. Yes, second. Let me see here. Element is end time and room index. All right. So counter this plus plus, and then main heap dot push. A new one will be room dot start dot first. Right, that's the end time plus current meetings start. No. Current meetings end. Then what does the start do? The start doesn't do anything. Right? Oh, start does do things because you need to know the duration. That's what we do. Minus m0. This is the duration because you're gonna start with room dot first is the end time. So you use that. Right, you use that. It's the start time. And hold. It depends, right? It should be the larger of the two. It should be the larger of the two. It should be the maximum of the room first or the start, right? Then plus this is the actual and. This is the actual and, right? This is the actual and. And we need to put room dot second, which is the index. Right, so we go through this, blah, blah, blah. Once we're done, we'll find the largest. So we go through them and we say int max count, right, is 0. And int max count is 0 and rest equal to 0. So say for int I, 0i smaller than ni plus plus, if counter I is larger than max count, say max count equal to counter I, and the rest equal to I. If it's equal, we'll skip, and at the end, we'll return rest. Alright, so this is my first solution. Let's try it. Looks good. Submit it. We have error. Okay, so what we have is two 13, 312, 710, 1719, 1819. Okay, so now we have 0, 1, 2, 3. So we take into 13. Next, we take this one to 12. Right, next, we do 10. Next. Yeah, so it start, so it doesn't end into 13, right? This is start is 0. So this is 17. 17. So I don't put here, because right now I will put here. Huh. That is interesting. Yep. Because when the time ends, so are you saying, so what are you saying? That the start with the smallest end time yeah, so first means the first one doesn't end until 13. Okay? And the second available is this, so we use that because it's not, you cannot, because it's not ready yet, right? It's not ready yet. 7 is also not ready yet, but 17, right? 17. Which means at a certain time tick, we should return this to 0. So basically, when we hit a new start time, we need to check everything here. Oh, how have to go through every single one. And if it's, holy crap, I think I need a separate array, which is to keep track of the current end time. And when a new one comes in, right, when a new one comes in, I go through that array. Like if there's anything that's so I reset that to 0. Right, I reset that to 0. Oh, I think this is like, it's like Dijkstra. It's like Dijkstra. So I'll counter and room earliest available. Earliest available. Okay. So everybody start with 0, which is fine. And every time we go through this, what we say is we need to go through everything for int I is 0, I smaller than n, I plus plus. Right? If earliest available I is smaller or equal to meeting 0, then earliest available I should equal to 0. So this is to reset the availability of each room. All right? And then what we're going to do is while min heap dot top holy crap, so I need the index and I need, so oh Jesus, so dot second is not equal to earliest available min heap dot top dot first. No, I think this is second. Wait, min heap, yeah, this is the first. First is the time. First is not equal to this. Auto room is min heap dot top, min heap dot pop, min heap dot push. Earliest available room dot second and room dot first. So this is to refresh the min heap to align with availability, current availability. This is very similar to how Dijkstra keeps track of the state, of the node state. Then we do the regular thing, right? Then everybody is the best, right? Everybody is the best. And then I don't need to do this anymore because the room is updated, right? So I can direct say room first plus this and then room second. All right, let's try this one. And we second. I don't understand. Why is wrong? What I'm saying is earliest available, if it's smaller or equal to the current meeting, right? That means it becomes available. So I set the availability to 0, right? And then I update the whole thing. And then here. This is wrong. This is room the first. Hold on, let me think one more time. So we have the current tick, right? Now I feel like this is still I think this I shouldn't change this. I think this is still, we need to get a maximum between this and M0. Yeah, we still need to get a maximum between the two. And that is still not right. Why? It is still not right. I'll actually check this. But it's still 2. What? I updated everything. Alright, so again, in this case, I have, because at the start, oh, I know why. Because I didn't update the current. So I blah blah blah, I do this, and main heap dot push. I might as well just get new end. It's new end is this, and then this will be new end. Yeah, I forgot to update. And earliest available update room dot second equal to new end. This one should be right. Come on. Ugh. The third one is still wrong. Okay, so we go through everything. Right, M0 is 2. Earliest version, everybody is 0. So we just reset everybody to 0, which is totally fine. And also this has to be I have to go N here. Right, so this is a fine. And then we say main heap on top first is not equal to earliest available, which is equal to, so I don't do this. So come here, main heap dot top, which is this one, right? And then counter, so 0, we get a counter. And new end is going to be room first is 0 plus, so it's going to be 13, right? So new end, so about got 13 in. And then the availability, give me 13, because it will be available at 13, right? At time 13. All right, next one, which is fine. So we're getting time, because it's 3, right? 3 is a 13, so I don't do, so everybody else become 0, right? And then at the top is 1 is at the top, right? So yeah, so we got this. So next one is 7, still nothing, so we got 10. Next one, 17. Okay, so 17 comes in. I first go through this. Everybody should get back to 0 because 17 is larger, right? So everybody becomes 0. Now the first is not equal to, so I pop it, right? Min heap, I'll pop it. And I'll put 0 in, so this will be 0, right? And then we say room will be this one. So counter, this should be counter plus. I don't understand, okay? I don't understand, so I need to debug. This doesn't make any sense. Like, I feel like I got it right, but for whatever reason, it didn't work. So this is meetings. So what do we have? 18, 19. What else? 312. 17, 19. 213. I believe it's 7 and 10. And n equal to 4. Okay, let's see, this is what? Most booked. And meetings. This is oh, let me do this. This is 710. Wow, we're entering. We haven't used this for a while. Okay. Where is your debugging? Let's put debug here. Okay. Oh, I forgot. What's that's F5, right? No, F2. Okay, meeting's fine. I'm more interested in this. But I'm not sure. Are we? Yes. This is what I'm interested in. Earliest available. This is also what I'm interested in. Counter, I'm interested in. Alright, so now we're good to go. Alright, so first M, which is meeting, I have 213. Good. We go through every one. So smaller, set to 0, set to 0, set to 0, and then set to 0. Good. Come out. Main heap first equal, so I don't do it. Jump out. Good. So room is 0, 0. So counter plus 1. New and should be 13. Main heap dot push. So we got 13 and 0 in. Perfect. Right? This is what we want. Second meeting. Second M is 312. Right? So go through. The first one is not. Second one, yes. So we reset 0, reset 0, reset 0. Good. Main heap first. Main heap top. Where's my main heap? Main heap top. Is not equal to? It is equal to, so I don't do this. Good. So room come out. Room is going to be 0, 1, yes. So counter, this is going to be 12. New one is 12. So I put 12 in, perfect. Next, shouldn't be any difficult. Yeah, this is 0, 2, perfect. So this should be 7. No, not 7, 10. 10, my bad, 10. And earliest, so that's the 10. Good. Now is the real interesting coming in. So 7, 10, right? 7, 10. So we go through here. The first one is smaller, so I reset to 0. Second one smaller, so we reset to 0. Third one smaller, reset to 0. Exactly. Fourth one, still 0. Now come out the top. Oh, now I see. You have to go through every single one. Huh. Well, I might as well use sorted list then. Right? Well, what's the point? Yeah, and I have to go through every single one. This is not gonna work. Might as well just go through the whole thing, right? To find the one with the largest. Yeah. Sorted list. Sorted list. So C++ sorted list. If I change a value in the sorted list, will the list be resorted? Does it have a sorted list? A set or a map? I'm not sure about the map because the end time can be the same, right? The end time can be the same. So when the end time is the same, so we need to sort it. Oh my god. Me god. Yeah, I know how to do it. I mean, we can just sort it. It's only 100 in size. So you do O and log n inside. Right? I don't see this as anything too difficult. Ah, Jesus. Okay. Yeah, we sort. We sort. So the earliest available. We'll change this. Okay. We change this into. We have to change this into a vector of int and int, so that I can. Unless you want to recreate a new one. Room state. What the hell are you doing, man? Oh, size 2. Right, so element is room index and time. Then we don't need this. We don't need a priority queue. Which means we'll put this one here. We'll say room state dot pushback I and a 0. Right, this is a room state, and it's also sorted. Counter is the same, and this is to check the availability. Right? So what we're saying is if room state I1 is the end time is smaller or equal to this, then room state I1 equal to 0. I mean, technically we don't need to sort, right? Equal to 0. How do we find, hold on, like a reset availability, reset the state of each room, right? Once it's done, we don't need to do any of this, we just need to find the maximum. Find the maximum room, index of the maximum room. How do I find the find max in vector with custom function? I don't know if it's possible. It is possible. Not find maximum, find minimum, right? So I think it's probably, it will return iterator, right? Yeah, so we say auto it find minimum. Main element, right? So main element, and now we have a compare. So we say main element from room state dot begin, room state dot end, and let's do this. This is gonna be vector int a vector int b. If a1 is equal to a b1, return a0. So I want a minimum, so it's smaller, right? a0 smaller than b0. Otherwise, return. Maybe hold a second. Hold a second. You want a minimum, right? So I just need to get the minimum on the end time. Yeah, we don't have to do a separate room index. And then we will change this. Still, it's a 0 and this is I. right? And then you only need to do this. You don't need to do any of this. But here has to change. So this is gonna be 0 and 0 reset. Yeah, reset is reset. And then, so we have a it, right? We have an it. So this is the one. So what we do is it second, no, it, I think it's, right? So this is iterator, which is the minimum element, right? Minimum element will go the minimum end time or the minimum room index. And then we counter do that. Because I choose it, and new end is going to be, is it the start, a maximum of these two, right? And then what we're gonna do is room state, no, now room state, we say it 0 will equal to new end. Okay, so m log m, and this is going to be, we go m times, and each time I go through n, go through another n. So it's like that. Alright, let's see if this one works. Does it work? Ah, shoot, the second one doesn't work. How? Right, so we start with 0, 0. This is where we start. Actually, no, that's not where we start. The state is 0, 0, 0, 1, and 0, 2. Okay, so we'll find the smallest. I think this one should be the smallest. Right, so counter 1, 2, so counter 0 is 1. New end is a 0 plus 20. No, it's not 0 because m0 is 1, so that's 20, right? So basically this will become 20. No, this is not this one. Jesus, man. The front is 20. The next smallest is this one, right? This is the smallest. So this will become 10. So this will be 1. Next one is 3. Start is 3, so I don't update. Because room state I0, 3 is nothing on this. This is the smallest. So counter to this, and then I'll put 3 here. Right. Next one is 4. 4 is larger, so this actually becomes 0, right? So 4 need to come in here. So this becomes 9. So this is 2. Huh? Oh. Hold on. Room state and earliest available. This has to be separate, right? Because it reset to 0. You don't know what its time is at that time. Ah, I see why this can be wrong. Yeah, you don't know what its time is. So like in this one, it should be 3, right? But you do 3 and 4. So yeah, it should be 9. Huh? It should be 9. Then this is the smallest. And then the last one is 6. Actually, this one goes... What? Alright, this is very wrong. This is very wrong. Oh, this is 5. N at 5. My bad. It's N at 5. This is 5, not 3. So when 4 comes in, right? When 4 comes in, nobody. So we'll pick the smallest. It should be this. Alright, so yeah, this still get 2. So new n is the maximum of this sum 4, which is 5, plus 5. So this becomes 10. Right, so this becomes 10. Next smallest should be this. So this is 2. Okay, so now we can check debug again. Yeah, I don't understand, man. I do not understand. They're really pissing me off, man. So what do we have? 120. Okay, 120. What's the next one? 210, 35. 210, 35. 210, 35, 49, and 68, I believe. Yeah, 68. N equal to 3. Rebuild it. Well, I would basically redo this whole thing. Do this, F5. Okay, so I have meetings. You already need meetings. Room state is more important. Room state. Y is 6. N equal to 3. I think I got this one wrong. This is for each room, right? So room 1 equal to I. that's the reason. Yep. I think that's the reason. Damn, overflow. Oh, this is unexpected. Okay. Yeah. No worry. We long this. This is fine. This is fine. This is fine. This is fine. This is going to be long. Unless long gonna overflow. That I don't think is possible. Okay, so we have some issues here. Oh yeah, because this is a long. This is not a long, because meetings is not long. Holy crap. So I need to cast this to long. Meanwhile, I need to cast... I think that should be good enough. Just cast one of them to long. Yep. There we go. Is it the best? Nope, but hey, we got it done. Job done. Mission accomplished. I consider this as a better performance than last time. If you take a look at last time, I had a lot more errors. This time I got 2. Okay, I got 2. Yeah, it probably has a better way. Sorting and counting. Sorting, counting is a priority queue. Yeah, I need to figure out how to do this in priority queue. I'm basically om log n. Yeah, this one is too long. There gotta be a priority queue way to do it here. But tomorrow should be easy, so let's read this tomorrow. I don't want to keep going today. It's good enough for today. Alright, that's good. It's actually pretty good. I'll see you guys tomorrow and read into this.